called the genu. And this portion back here is called the fornix. There's all kinds of terms that go along with it. But what's really cool is the ventricles of the brain. This is what I was trying to get across to you with the model that's probably right over there. Shows you the thing that it's kind of greenish gray, and it's a small model, and it's probably right on the other side of it. That shows you the ventricles of a human brain. The ventricles of sheep brain are very similar, meaning you're going to have a ventricle here, a ventricle here. Across here is the septum pellucidum. That's the septum that actually separates these two. Yeah, you got a ventricle like, that's the human brain though. I'm showing you with my hands the sheep brain, but it's the same thing. And so that's a fluid-filled space that you see there in between these two cerebral hemispheres. Okay, so separating in between, same thing in human beings, is a cross wall that's called the septum pellucidum. It basically keeps all that cerebrospinal fluid from sloshing around on both sides. 4 ventricles. So you got ventricles 1 and 2. They're not named. They're just called lateral ventricles. If they were going to be named, you go 1, 2. Third ventricle, right here. Third ventricle. 1, 2, third ventricle, fourth ventricle here. Okay? Same thing is going to be true on my sheep brain. Oh, this is perfect. Can you see how this one is not open, meaning I'm seeing the septum pellucidum right there. This one is open, meaning they didn't cut it exactly down the midline. It's almost impossible to do anyway. But you can see this is open. And my forceps actually go quite a ways up into there. They go up to about right there. Put these two together. That's ventricle 1, ventricle 2. The foramen of Monroe is going to connect up each lateral ventricle with the third ventricle. The third ventricle is going to surround this rounded structure right here. Now this is like critical thinking. Why is it that when y'all look at this, you see a rounded structure? Why doesn't it look like a square? Why doesn't it look like something else? Because this structure is a solid mass that all the way around it has a conduit or a tubule. It's topographic low. If you cut it down the middle, it means on either side I'm going to see a rounded solid structure, because there's a tubule, very thin, but it goes all the way around this structure. This is called the thalamus, or you can call this the interthalamic adhesion. So the conduit goes all the way around. It connects up. Well, that's the third ventricle. Third ventricle surrounds this thalamus. Okay? Okay. It's going to be, and you say, ooh, show me, I want to see it. Yeah, I can't. It's right there, based upon its location. It's a thin, little, teeny, tiny, narrow conduit. It's going to go from about there. Remember, that's a lateral ventricle. That's a lateral ventricle. It's going to go from about, actually, it's a little bit further up than that. It's going to go from about there to here. It's going to go all the way around. Foramen of Monroe. The fourth ventricle, this is the cool one. It's like nobody would predict what this thing looks like. Ooh, and this is a little bit boogered up. Fourth ventricle is going to be this little notch that you see right there. It's a little bit busted up on this one. Let me see if I can find another one. Gee, this is even worse. Oh, there it is. See this little notch right there when I put pressure on it? That's the fourth ventricle. The fourth ventricle is going to connect to the third ventricle via the aqueduct of Sylvius. The aqueduct of Sylvius, this is so cool, actually. The aqueduct of Sylvius is going to take this path. Remember, this was the thalamus, and then I've got a little conduit that goes down here. It goes down here. And then there's like a little leaf of this cerebellum. It's going to dip down here, come down, and if that was cut straight, it's going to connect up to this fourth ventricle there. So the aqueduct of Sylvius is just a thin little passageway right along here, comes up and attaches there. This was the superior colliculus. This is the inferior colliculus. That's the thalamus. Raised topographic areas, those are gyri. Gyrus would be singular. The depressions, the thin ones, are going to be called sulci. Sulcus would be singular. And then the deeper passageways are going to be, or depressed areas are going to be the fissures. This is the longitudinal fissure. This area that looks, now that it's drying out, that looks very fibrous, this is the pia mater. Now ask yourself this question: why do you see what looks like dried blood in these sulci? Because that's what it is, dried blood in those sulci. Why is it that some of these brains don't seem to have any dried blood in there at all? It's because when they killed them, they allowed the blood to drain out first before they preserved them. So it's not that big of a difference between the two. In terms of the cerebellum, this is called the tree of life, arbor vitae. Tree of life is vitae, arbor's tree. In Spanish, arbol is tree. Same mother language. This is, going back to what you were saying, I think, or one of y'all was saying, this is the white matter in the cerebellum surrounded by gray matter. So this is white matter, meaning it's got the coating, myelin sheath on the outside of it. This is the gray matter on the outside. Tree of life. Now, interestingly enough, at some point y'all are going to have your own vita. If you're going to be a scientist, you have your own vita. Some nurses have produced what's called a resume, but most of you have a vita because it actually fits in better, meaning you're going to receive training for, different types of first aid, and you're going to get various different certifications as you go along. And it's good to keep track of those because they have to be updated. I mean, I got CPR and all that stuff years and years ago. I haven't updated any of that stuff. Hopefully I still remember some of it.